Welcome to this screencast on compound interest. What I mean by compound interest is that I put some money aside and it earns some interest, and then the full amount of both my original investment and the interest added to it is what's involved in earning the next amount of interest. Let's say that I'm considering putting $100 into an account and it's going to earn 4% annual interest. If 0 years has elapsed, that implies I've just put the money in the bank. The value is obviously $100. If another year elapses, then I would have now $100 times 1.04, since if you remember right, this is our multiplier that increases 100 by 4%. Year 2 comes up, and after 2 years have elapsed, the amount of money that I now have is what I had before, which was this amount. And then all of this ends up being multiplied by another 1.04, since it's that new balance that gets increased by 4%. After 3 years, I have what I had on the previous year, which was this amount. And then that's my current balance, so that's what's going to increase by 4%, so that tacks on another multiplier of 1.04. For convenience, I may want to write a formula that would calculate how much I have in my account after a certain number of years have elapsed. So we can kind of see enough already in this chart to find out this particular formula. So the future value of this account, which remember we're going to use the letter F to refer to the future value, notice in every single one of these cases, this number right here is my original amount. So I'm going to go ahead and write down equals 100. And then there's a certain number of 1.04 multipliers. And however many there are, if there's 0 years that have gone by, there's none of those 1.04s. If there's 1 year going by, then 1.04. If there's 2 years that have elapsed, then we have that multiplier occurring 2 times, and so forth. You can see that the number of times this multiplier occurs seems to match the year. So what I'm going to do is I'm going to go ahead and put a variable, t, which stands for time. In this case, the time is in years. And this formula would now tell me how much my original investment was now worth at any given year I wanted to know. To generalize this a little bit more, it may not always be $100 that I want to put into the account initially, but you can imagine that regardless of how much I put in, it's always going to be the number that occurs at the head of this calculation. So if I further generalize this, the future value of an investment is equal to the present value, or the amount you're putting in today, times this multiplier that increases things by 4%, with the exponent being t. In this case, t is representing the amount of time and years that I leave that money in the account. Just a reminder, last year, if you remember where this particular multiplier came from, it came from the 1 that we need to have so that the multiplier adds back the increase to our original amount, and the 0.04 is actually what's causing the increase. So last year this formula would have looked like something like this, where F is the future value, P is the initial amount that I invested, and the 1 plus R just means that 1 plus 0.04, that rate of interest I'm getting. So that's where the 1.04 came from. Now, I'm sure you've probably had an account, a savings account or a checking account at this stage of your life. And if so, you would recognize that banks don't generally wait to the end of a full year in order to give you your interest. Usually they offer to compound it more frequently than that. If a bank says that they're going to compound quarterly, what they're saying is they're going to give you interest 4 times each year. And they're not going to give you 4% at one point, and then 4% at another, and 4% at a third time, and 4% a fourth time, because that would be closer to 16%. Instead, what they're going to take your 4%, which is 0.04, and they're going to chop it up into 4 equal increments. In this case, this would come out to be 1%. And they're going to give me 1%. They're going to give it to me 4 times throughout the year. So let's see what effect this has on our formula. What it means is now they would take the $100, and after 1/4 of a year, which is 3 months, they would multiply by 1.01 instead. After another 3 months go by, they take what I have so far, which is this amount, and they multiply that by a 1.01. Now, after all that time has elapsed, when we go into the third quarter, in other words, when we've gone 3/4 of the way through a year, they're going to take what I have so far, which is all of what you see here, and they're going to multiply that by a 1.01. And then go again for another 1/4 of a year, which is the last 3 months of the year, and they'll take what we have so far and multiply that by a 1.01. Notice that the multiplier is affected by the fact that I'm getting my interest rate more frequently than just once a year. So my repeated multiplier is no longer 1.04, but rather 1.01. And also notice that for just 1 year's time, I've used my multiplier 4 times. Let's generalize what effects this would have on the formula that we would use. So our future value, notice at the front of this calculation is our present value, or the amount we invested. And instead of 1 plus r like it was before, it's going to be 1 plus r chopped into how many times in 1 year it's going to give us the interest. So it's going to look like 1 plus my annual rate of interest divided by the number of times during a year they will compound my interest. Then to ensure that the multiplier, the 1.01s, occur the right number of times, it's going to be 4 times per year times the number of years that I leave the amount of money in that investment. So basically, this number always has to be the total number of times that the bank will use the multiplier. And if it's this many times per year, and it's this many years I'm leaving it in, we multiply together in order to know how many times we're going to use our multiplier. So in this particular case, the formula for this scenario would be $100, 1 plus my annual rate of interest. They did promise me 4%, chopped into 4 increments because they're chosen to give me my interest quarterly. And then this will be a 4 because I'm getting paid the interest 4 times per year. And for now, I'm going to leave a t in the formula so that I could use this for any amount of years. The answer that I get to this calculation ends up being 148.8863,734. And as far as how you leave your answer, since this is money, we always leave it the way money is calculated expressed in that particular country, we have the smallest unit of currency being a penny. So we're going to round to the nearest penny. So I'm going to go point, and I notice that this first digit after the 88 cents is a 5 or bigger. In this case, is 6. So what that means is I'm going to round up to 89 cents. If this had been a number smaller than 5, I would just truncate, throw away all those digits, and just keep it as 88. So always when you're doing a financial problem and you're computing a certain amount of money, always round at the end, but round to the smallest unit of currency in the country that you're dealing with for the problem. So as a recap, our financial formula for doing compound interest is going to be the future value of the money is equal to the present value of the money times our multiplier, which we form this way, 1 plus the annual rate of interest written as a decimal divided by the number of compoundings, all raised to the number of compoundings times the number of years. We will use this formula all of the time that we're doing a compound interest problem, with the one exception of when we're doing continuous compounding. The continuous compounding is a different formula, and we'll cover that in class. Keep in mind, this is compound interest, not to be confused with simple interest. Simple interest, like the bond interest we did last week, that uses an entirely different formula. That uses the F, future value, is equal to the present value times 1 plus the rate of interest written as a decimal times T. So this would be called simple interest. We're always using the simple interest formula. If they mention it, we're using this for a majority of all the compound interest. There is one other formula you learned last year, which you probably referred to as PERT, and that is the formula we'll use in the one circumstance where we do continuous compounding. Just as a note, we just did a problem where the compounding was annually. That was just a little bit earlier. And notice we didn't, our n in that case is just a 1. And when we do semi-annually, that would mean we're compounding twice a year, so the n would be a 2. We just did an example most recently where our n value was a 4. It was quarterly. The most common type of compounding would be monthly, and there you would have n equal to a 12. If you were compounding weekly, your n would be a 52. And you could even figure out what n would be if it was hourly or if it was minutely. You just have to go figure out how many hours or minutes there are in a year. One last important note before you go off and do the textbook problems. If you take a bank's offer to pay you annual interest with no mention of a more frequent compounding, that means you're going to pay your interest annually, just once at the end of a year. So if you leave that amount of money in the bank account for 1 year and 11 months, it actually won't give you any interest for that second year because it only pays after a completion of a year. If you take out an investment and it's paying you quarterly, if you leave it in there for 1 year and 3 months and 2 weeks, it will give you the 1 year, 3 months, because that's going to compute the quarter in the second year, but it will ignore the 2 weeks beyond that because it isn't the full quarter. So you have to pay attention to little things like that, and that will help your answers come out to the answers you see in the answer key. I hope this screencast was useful.